Hello everyone and welcome to the channel. My name is Harold Campos and today I will be speaking about RabbitMQ with Azure Logic Apps. So what is RabbitMQ and why is it important? First of all, it was invented or brought in 2007. It was created by Rabbit Technologies and a joint venture between Shift and Cohesive FT. It's a message broker. RabbitMQ is an open source message broker that enables asynchronous communication between applications. There are multiple others, and we will be talking briefly about other alternatives as well. It does support AMQP. It's built on the advanced message queuing protocol, and it ensures reliable and flexible message delivery. It decouples services because it helps separate microservices, improving scalability, fault tolerance, and system resilience, of course. And it's enterprise ready, right? So you can use it in the cloud, hybrid, and on-premises setups. Now it's integrated into Azure Logic Apps for hybrid messaging scenarios. And we will be talking extensively about this in the next 10 to 15 minutes. We have provided now a connector, the in-app connector for RabbitMQ that is available for Logic Apps standard and hybrid. And basically, the idea of this connector is to allow receiving and sending RabbitMQ messages. For receiving, we have a trigger, and for sending, we have actions, and we will go through them very soon. The way how it works is that the RabbitMQ in-app connector enables connections between Logic Apps workflows to RabbitMQ servers on premises or in Azure by picking, receiving, or sending messages stored in a RabbitMQ server. We have also provided the ability to create queues as well. The way how we create a connection to a RabbitMQ server is via a connection string. The connection string is this is the format: AMQP, username, password, hostname, then the port and host, a virtual host. If the host doesn't contain a virtual host, then the connection string should end with a trailing slash towards the end. It supports exchanges and binding keys. Exchanges are the entities where publishers publish messages that then are routed to a set of queues. And as I said a few minutes ago, a RabbitMQ connector uses AMQP. Now, why is this important? Why is important to have a RabbitMQ option? As I said, we provide triggers and actions. For triggers, we have the ability to integrate with to bring and read messages from a queue when they are available, and we also have the ability to do pick lock, right? So then when we have pick lock, the received messages are locked but not deleted from the queue until a call to reject complete. This is what we call a non-destructive read. As far as actions, each subsequent step in a workflow that follows the trigger, the connector can send and complete messages. We can also create queues. If we talk about non-destructive reads, like the way using pick lock, we do have a requirement, and we call it a stateful mode or affinity enablement. The pick lock returns one or more messages from a queue. The received messages are locked but not deleted from the queue. Now, while this pick lock operation is atomic, what is important is that we enable this state preservation feature in Logic Apps that allows to confine the sessions in a specific number of virtual machines, right? So then, to enable these scenarios, you have to enable what we call affinity, right? And basically, the process is fairly simple, and is required for this connector. You have to specify a number of VNet private ports, so you require VNet integration, of course. And you will most likely use it anyway. But if you don't, still you have to allocate these private ports. What is important to say is that this stateful mode for stateless built-in connectors in Logic Apps is a bit of a long name. It will allow you to provide the ability to lock messages and do a non-destructive read. And this is basically because the platform requires you to specify a finite number of instances and ports that will be using this connector. Now, this is required by RabbitMQ, by IBM MQ, but it's no longer required by service bus. So the difference is because we do not own neither IBM MQ nor RabbitMQ. So then we have to rely on what these technologies provide, right? And in the case of service bus, we do own the technology. So then that's why we are able to provide this session support, and then you don't really need to enable affinity. What I wanted to do, though, is I wanted to include a number of messaging technologies for which we are providing support, and then providing some recommendations as to when to use them. Well, first of all, you know that Azure Service Bus is a Microsoft product, right? And then there is the list of all of the capabilities that it supports. What is important to say is that we have a lot of freedom with Azure Service Bus because, again, we have control on the product. But on the other technologies, we have IBM MQ, we have a Confluent Kafka connector as well. We are providing a private preview for an Apache ActiveMQ connector as well for JMS, and RabbitMQ. For all of these connectors, we have different characteristics, right? And we introduced RabbitMQ and Confluent Kafka additionally to JMS for on-premises and Logic Apps hybrid scenarios, because today we don't have Azure Service Bus on-premises. So then for customers who want to implement Logic Apps on an on-premises environment, it's difficult to accomplish, the most common patterns that we had in Bstock server, for instance, or patterns that would require you to do convoys, for instance, or to do persistence and then redirection and then using of topics and using topics and such. So then we thought about providing these connectors for customers to do their own messaging implementations on premises. IBM MQ is supported in a standard and in the cloud and on premises, on hybrid as well, and has been around for many years. And Kafka and RabbitMQ, they were released in public preview recently, and ActiveMQ /JMS, Apache ActiveMQ /JMS is a technology that is also widely used by for enterprise messaging, JMS-based apps, and in banking and financial services scenarios. So then, with this, we believe that we are providing the right messaging alternatives for customers that are looking to implement their messaging patterns on premises. And this is important also in the context of other offerings that we will be shipping very soon in the product. Now, let me show you the RabbitMQ in-app connector. We have RabbitMQ server, and this is a service that we just set up recently, and all of the configuration that you can add to the exchanges, the queues and streams and everything. Basically, what I did is I created 3 workflows. I'm going to show you the purpose of each one of them. I have this workflow that does it sends messages, right? So let me go to the designer and show you what I'm using here, right? This one does 2 things, right? So I added a trigger for when an HTTP request is received, and then I send a message to this queue that is called test queue. The body is hello RabbitMQ, right? I mean, you also have the ability to add an exchange name or a routing key if you use them for redirection and for topics. And I added create a queue as well, right? Which is basically generating a random name for a queue plus a random number whenever it creates a queue. And the reason why I did this is because I wanted to show how this works, right? So this is the send and the create a queue. Now there is also another workflow which is called the receivers workflow that has what I call the let me show you the peak lock, right? So in the case of peak lock, there is something, if you remember, a few minutes ago, I mentioned that we need to enable affinity, right? And affinity, you have to set it up, or the VNet ports and everything, you have to do that from the cloud. Right now, I'm using a local VS Code instance, so we cannot add this configuration to VS Code. So I'm going to show you how it will fail and how it behaves. But then I will show you also another. I mean, this fails here, but it won't fail when you deploy it to the cloud, right? When you run it in the cloud and you have the proper configuration. And I will also show you the autocomplete option. That is basically the the alternative that does a destructive read. So in this case, when there is a message in a queue, then we read it and we send that message. So then you will see that there is a difference in the server. I'm going to show you the differences in just a minute. Yeah, the configuration is fairly straightforward, and the connection string follows the format that I just showed in the presentation a few minutes ago. So let me try sending. And the other thing is I have not set up for VS Code to run. They are reusing the same port, so they'll stop each one of the workflows after I have them doing what they are supposed to do. So then I start with the sender. I will run the sender, and I will then call the trigger, and you will see what happens in the server. So now, in the meantime, let's go to see what we have here. So all of these queues, they have been created in some previous tests, and then you will see that I have two queues here that are empty now, test queue 1 and test queue 2. I'll do refresh anyway, right, to make sure that they are still empty. Yep, they are empty. And I'll go to the sender that I just started. It's starting, and then I will go to overview, right, and then I will run the trigger, right. So then when I run the trigger, you will see that in the RabbitMQ server, so two things should happen, right. One is I created a queue, of course, right, and you saw that the list grew, and then I have an active queue called test queue 1, right. So then it created a queue, and then it sent a message to test queue 1, right. You see that there is one ready here, and then what I'm going to do is I'm going to stop this for a second, right, and then I'm going to go to the receivers that has the peak clock, right. As I'm missing the configuration for affinity, I don't really have a way to specify the VNet port set to 2 or following the instructions of configuring the affinity to confine the execution of this trigger, then it's going to fail. But I'm going to show you what happens, because this is also important to know, right? So I'm going to run it, run, start debugging, and then you see that I still have this one message ready here, right? And you see that you have ready or an act. You know, in RabbitMQ you have, well, we call them complete or reject, is act or an act, right? So we are implementing mirror operations for doing this non-destructive read. You will see that there is a one act message, and there is another message here in the queue, because every time that I do that I call this workflow, what it does, it reads from the trigger from this queue, right, and then it sends a message. The content of that message, it sends it to another queue, right? Well, I mean, not the content, data. It's sending the data word to test queue 2, but it has the complete or reject. Now, if I go to the overview, you will see that this has failed, right? And then if I get into the details of why this failed or where it failed, you will see that it was able to capture the queue, right? To read it. Yeah, so it read the queue successfully, and then it sent the queue, the content of data that I had, and then it failed completing it, right? So it failed completing the message. So because it was supposed to complete the message, and then when I see what happened, you'll see that you know, the service provider action failed with the error code, VNet private port not configured, an error message using this service provider action in stateful workflows requires VNet integration and the site to be and the site configuration VNet private ports count to be set to a value greater or equal than 2, right? Because we need to allocate these ports for this traffic across instances. This is a requisite of AMQP of the protocol. So then they have to communicate to each other. Now, so it fails. So then what happens in the portal is that you will see that there is one act message here, right? But still you see the count 1, right? And then you see a test queue, the message that was sent successfully for test queue number 2, right? Now, if I stop, so let me stop this. I think it was this one. Yes, this was the one. If I stop the program, right, or the logic app, or you know, that is running, then I'll go back to the portal, right, and you will see that there is a change now in test queue, right? The message was an act first, then now it went back to what it was, right? So it's still ready, read. It's still ready to be consumed, right? So it has not moved. It read it, but as it did not complete it, it just left it there where it was. Now, if I added the VNet port configuration in the portal, as I said a number of times, you can you will see a difference because this will be processed and it will be complete. You won't see anything here. Now let's try using the autocomplete. The autocomplete is the one trigger that has the ability to just do a destructive read. So it will get the message, right? So it will get the message and then it will send a copy to it will send data to test Q2. Now I'm gonna run it. I think I stopped running. Yeah, I stopped the run of the other one. I'll do start debugging and you'll see what happens. Okay. Now you will see that it was an act total, right? And there was a send here, it's still in process. Now I'll do refresh. You will see that the message is gone from test queue one, and but we had two messages in test queue two, right? So this means that that it was read successfully, but it was taken out of the queue, right? So then you have the alternative of doing a destructive read. It depends on your scenario, right? We typically recommend customers to do non-destructive reads because if something happens in transit, even in a stateful workflow, things can happen. Then we don't want you to have your queues left in an inconsistent state. So that's why it's important for you to see the difference across all of these modes. Just to recap, right? So we are providing in Logic Apps a RabbitMQ connector that is available for Logic Apps Standard and Hybrid. The reason why we have added this RabbitMQ connector and Confluent Kafka connector and ActiveMQ, Apache ActiveMQ with JMS is because on premises we don't have Azure Service Bus, so then we are letting customers to use their own messaging system, right? So then they can incorporate all of these patterns that you have available, and then for instance you can receive from the trigger, and then instead of sending to RabbitMQ, you can send to MQ or to Service Bus or to anywhere else, right? What I'm going to do now is I'm going to wrap up. Thank you so much for your time. If you have any questions, please drop them in the comments and subscribe to the channel. I'll be adding more information and about technologies, product management, and integration, which is an area that I love working with. Thank you so much.